This is Lindsay Clark, your primary instructor for current topics in medical laboratory sciences. This is lecture 24. It is part 1 of lab math. So the objectives for today's lecture are, number 1, define terms associated with laboratory math, including solvent, solute, aliquot, dilution factor, simple dilution, serial dilution, and multiple dilutions, among others. Number 2, discuss the difference between quantitative and qualitative results. Number 3, calculate a simple dilution. Number 4, determine the amounts of solute and solvent needed to form a specified dilution. Number 5, determine what volume of solvent to use when a set total volume of solution is required. Number 6, recalculate a patient result when a specimen has been diluted for an assay. And number 7, determine the concentration of a solution after it has been diluted. So we'll start with some terms and definitions. I know that this is probably a review for most of you, but it's still a good refresher. So these definitions are important, and I want you to know these. Solute, solvent, diluent, solution, and aliquot. And I will let you read through those definitions. And a few more definitions. I want you to know these as well. So we have dilution factor, dilution ratio, simple dilution. And the coffee cup here kind of represents a very simple dilution that a lot of people do every day. So today we're talking about simple dilutions. And with coffee, people might add water to their coffee if they make it too strong, and that's a dilution. Or they might add creamer to their coffee, which is also a type of simple dilution. So just remember, when we're talking about simple dilutions, we're talking about sort of two parts put together to make a dilution. Just briefly, I want to mention the difference between qualitative and quantitative lab results. Qualitative results basically tell you if a certain compound is present or absent. So examples of this would include the presence of glucose in urine, bilirubin detected in the brain, or a positive urine pregnancy test. So it boils down to, basically, it's either there or it's not. Quantitative results, however, determine the exact amount of a compound present. For example, if you had 405 micromoles per liter of uric acid or 9.0 millimoles per liter of glucose, those would be quantitative results. So thinking about these two different types of lab results, which one do you think will likely involve the most lab math? Units of measure. So the International System of Units, which we refer to as SI units, this is a standardized system of measurements that was adopted by the scientific community in 1960. So the common units seen in the clinical lab are going to be length, maybe not as common, which we measure in meters, mass, which is measured in kilograms, volume in liters, and temperature in degrees Celsius. So the next few slides are going to be some charts, and these charts are really here for your reference, and I'll put these will be in the lecture manual as well. So the prefixes in this chart are used to indicate a subunit or a multiple of a basic SI unit. So remember, if you are converting smaller units to larger units, you move the decimal to the left. If you're converting larger to smaller units, you move your decimal to the right. So these are just a chart that has the prefixes, how it's abbreviated, the exponent, and then the decimal. And again, this chart is just for your reference. So this is a chart to really convert sort of units you'll find here in the U.S. into SI units. So there's times that we have not fully embraced the SI units. And so you'll still see things that are measured in fluid ounces or pounds. So this chart will tell you how to convert those into SI units. And this is a temperature conversion chart. So it includes conversion for degrees Celsius to Kelvin. That conversion is not going to be used a whole lot in the clinical lab, but you might see it every now and then, so it's good to know. And then there's how to convert Celsius to Fahrenheit and then Fahrenheit to Celsius. Again, just for your reference. And these are some really simple conversions, just to kind of remind you what these look like. So if you had a length of 1 centimeter, you could use the chart to convert that to millimeters, and you would have 10 millimeters. Or if you had 1 liter, you can convert that into milliliters, and you would have 1,000 milliliters. So that's just a really simple sort of conversion chart there for you, again, kind of for your reference. So just quick practice for you guys. We're going to work through these problems real quick. So if you have 300 centimeters, you convert that to meters, it's going to be 3. 25 millimeters converted to meters, you're going to move the decimal to the left 3 spaces, and you end up with 0.025 meters. 4 meters converted to millimeters, you're going to move your decimal to the right 3 places, you're going to end up with 4,000 millimeters. So 0.1 meters converted to millimeters is going to be 100. 500 millimeters converted to meters is going to be 0.5. And 50 centimeters converted to millimeters is going to be 500. So let's do some mass conversions. If we have 0.1 grams and we want to know how many milligrams, we're going to move our decimal to the right. We're going to move 3 spaces and we get 100 milligrams. 10 milligrams converted into grams, going to move your decimal to the left, and you will end up with 0.01 grams. Now, 1 microgram converted to milligrams is going to be 0.001. And 175 milligrams converted to grams, going to move your decimal to the left again, you will end up with 0.175 grams. 30 milligrams converted to micrograms, you're going to move your decimal to the right, and you'll move it 3 spaces over, and you will end up with 30,000 micrograms. And 0.4 grams converted to milligrams, you will move your decimal to the right, and you get 400 milligrams. And let's do some practice converting volume. We're going to do a couple more of these because you will be converting volume a lot in the lab. I know you guys probably are doing this, some of you. So 50 milliliters converted to liters. Going to move your decimal to the left. You end up with 0.05 liters. 0.5 liters converted to microliters. You're going to move your decimal to the right, and you will end up with 500,000 microliters. 250 microliters converted to milliliters, and you will have 0.25 milliliters. Now, 4 milliliters converted to microliters equals 4,000 microliters. 0.5 liters converted to milliliters. Going to move your decimal to the right. You will have 500 milliliters. 0.1 milliliters converted to microliters. You're going to move your decimal to the right. You end up with 100 microliters. 20 microliters converted to milliliters. You're going to move your decimal to the left. You end up with 0.02 milliliters. And 500 microliters converted to milliliters, You're going to move your decimal to the left and you end up with 0.5 milliliters. So dilutions, these are going to be performed in the lab on occasion. And times that we would see these performed in the lab would be if a patient value result falls outside of the linear range. You would have to dilute that specimen and rerun it. If antibody titers need to be determined in patient serum, they'll do dilutions to determine that. Or if you have a concentrated stock solution that requires diluting. The one thing that comes to mind to me that I did in the lab a lot as far as dilution from a concentrated stock was our cleaning solution. We would change them out every week, and we had to make a certain dilution of our concentrated cleaning solution, and we poured those over into spray bottles for cleaning up the lab. So I know this image down here is blurry. I couldn't find a nice clear one. But this is an image of an RPR, and it has the qualitative test on the top and the quantitative titer on the bottom. So on the bottom, if you look close, you can see the dilutions and the results of each circle. So you have undiluted, a 1 to 2, a 1 to 4, a 1 to 8, and a 1 to 16. So looking at this, the undiluted is reactive, the 1 to 2 is reactive, the 1 to 4 is reactive, the 1 to 8 is non-reactive, and the 1 to 16 is non-reactive. So looking at this, you can say that your titer is 1 to 4, and that's a really good example of where they would do dilutions in the lab. Simple dilutions, that's what we're going to deal with today. A simple dilution is the ratio of concentrated or stock material to the final volume of a solution. So there are two parts in a simple dilution: the sample to be diluted and the diluent, or whatever other reagents are used to make the dilutions. So remember our coffee example. We have our coffee, which is our sample to be diluted, and then your water, which would be your diluent. So the formula to determine the dilution ratio is sample volume over sample volume plus diluent volume. Or we can reduce that down to a simple sample volume over total volume. For me, I prefer the simplified version of this formula, but whatever works best for you is what you should use. Okay, so let's work through this formula. So for example, let's say we have a 1 to 10 dilution, and the 1:10 is verbalized as 1 to 10. So this means for every 1 part of sample, there is a total of 10 parts solution. So if we have 1 part serum, we need 9 parts diluent to equal 10 total parts. For me, if you replace part with something like milliliter, it sort of makes more sense to me in my head. So if you do that, then we can say we have 1 milliliter of serum plus 9 milliliters of diluent. That gives us 10 milliliters of total volume. So another example, if we have 1 milliliter of serum, we mix that with 3 milliliters of diluent, then our final dilution is 1 to 4. We know that because we have our initial sample volume, which is 1, and that's over our total volume, which is 1 plus 3, so that's 4. And this can actually be written two different ways. So you can have 1:4 as a 1 to 4, or you can write it as a fraction, 1 over 4. Both of these are acceptable ways to write these out. So here's the major thing. Moving forward, we will determine the dilution by dividing the total volume by the volume of sample being diluted. So let's talk about this a little bit more. If we have 0.5 milliliters of serum and we mix that with 2 milliliters of saline and 1 milliliter of reagent, what's the final dilution? So first we need to add up all the parts to get the total volume. So we add all of those up and we get 3.5 milliliters for total volume. Then we want to divide the total volume by the original sample volume. So we have 3.5 total volume. We just figured that one out. And then our initial sample volume is 0.5 milliliters. So we have 3.5 total volume over 0.5 sample volume, and that gives us 7. And this means our serum is diluted 1 to 7. So what's the dilution factor? Remember, if you read through your definitions, the dilution factor is just the reciprocal of the dilution ratio. Now, that means our dilution factor for this problem is simply 7. And that's it. It's that easy. So here are some practice problems to work through. There is a document that's posted in this module that you can print out. It has all of these practice problems on there if you want to work these out as we go along. So simple dilution practice problems. Number 1, if a 1 to 8 dilution of serum is required, how many parts of serum and diluent should be combined? So if we have a 1 to 8 dilution, we know that 1 is the volume of our sample, right, our original sample, and 8 is the total volume. So we can say we have 1 part serum plus X amount of diluent equals 8 total parts. So the answer is we should have 7 parts of diluent. If 1 milliliter of serum is mixed with 14 mils of diluent, what is the final dilution? What is the dilution factor? So we have 1 milliliter of serum plus 14 milliliters of diluent. And that gives us 15 milliliters of total volume. So what is the final dilution? Well, we've got our original sample volume, which is 1, and then we have that over our total volume. So 1 to 15 is our final dilution. Now, what is our dilution factor? Again, it's just the reciprocal of your dilution ratio. So dilution factor is 15. So some more practice problems. Number 3. If 0.5 milliliters of serum is mixed with 9.5 milliliters of diluent, what is the resulting dilution? What is the dilution factor? So we know we've got 0.5 mils of serum. That's our original sample volume. We're adding that to 9.5 mils of diluent, which gives us 10 mils total volume. So to find our final dilution, remember we're going to divide our total volume by our original sample volume. So we get 10 divided by 0.5, which gives us a 1 to 20 final dilution. So what's our dilution factor? For this problem, it is 20. So number 4, if 0.2 milliliters of serum is mixed with 3.4 milliliters saline plus 1.4 milliliters of reagent, what is your final dilution? First, we're going to add up all of our parts to get our total volume. So we've got 0.2 milliliters serum plus 3.4 milliliters saline plus 1.4 milliliters of reagent, which gives us 5 milliliters total volume. So your final dilution is going to be 5, your total volume, divided by 0.2, which is your original sample volume. So your final dilution, 1 to 25. Now, even though this question doesn't ask, your dilution factor here is going to be 25. Okay, so what if we need to make a dilution, but the total volume is set for us? Well, there's a formula for that. So your formula is going to be sample volume over total volume equals X over total volume. So, for example, a 1 to 5 dilution of serum needs to be made. the total volume of dilution must equal 100 microliters. What volume of serum and diluent are needed? So first, we need to set up our equation. We've got 1 part serum, which is sample volume, over 5 parts, which is our total volume, and that equals X over 100 microliters. So the 100 microliters is our final total volume. So if we work this out, this gives us 5x equals 100, then x equals 20. But we're not done yet. So this means that we need 20 microliters of serum. And we know we have 100 microliters total volume. So how much diluent will we need? Well, we will need 80 microliters of diluent. So let's do a couple practice problems. A 1 to 2 dilution of serum is needed. The total volume must be equal to 50 microliters. What volume of serum and diluent are needed? So first we need to set up our equation. So we've got sample volume is 1 over total volume, which is 2, equal to X over total volume, which is 50 microliters. So if we calculate this, we get 2x equals 50, and then we get x equals 25, which gives us the amount of serum needed for that dilution. So remember, it's asking about serum and diluent. So if we have 25 microliters of serum plus X amount of diluent, and we know that's equal to 50 microliters of total volume because they told us so, then we can calculate that and figure out that we need 25 microliters of diluent. So, second practice problem here. A 1 to 4 dilution is needed, but only 100 microliters of serum is available. How much diluent should be added to the 100 microliters of serum? So notice that this question is going to have us set up our formula just a little bit different. So we know that we have a 1 to 4 dilution. So we have a 1 sample volume over 4 total volume. And we're going to set that equal to 100 microliters over X. So they give us the amount of serum, not the total volume. So we're going to calculate how much diluent we need. But first we have to figure out the total volume. So we solve our equation, we get X equals 4 times 100, so X equals 400 microliters total volume. So now that we know our total volume, we can determine how much diluent. So we have 100 microliters of serum, which we know because they told us, and we have 400 microliters total volume, which we know because we calculated, and so we can determine that we need 300 microliters of diluent. Now, we have already learned how to determine the dilution factor, but what do we do with that? Why is that important? Well, let's say a patient result is too high to measure on an instrument. It's either out of reportable range or out of linear range. So a dilution of the patient sample has to be made, and that sample has to be reanalyzed. But is the result you get from a diluted sample the final result? No, it is not. So always remember you must multiply the result from the diluted specimen by the dilution factor to get the final result. So for example, a patient's serum ran outside the linear range of an instrument. The serum was diluted 1 to 5 and rerun with a result of 30 milligrams per deciliter. So what is the final patient result? So remember you must multiply the result, which was 30 milligrams per deciliter, by the dilution factor. In this case, that's 5. Now this gives us 150 milligrams per deciliter, and that is going to be your final result. So here's our practice problem for this. A patient's glucose result is outside the linear range of the analyzer. A dilution is made using 10 microliters of serum and 90 microliters of diluent. The diluted sample was reanalyzed with a result of 75 milligrams per deciliter. What glucose value should be reported? So what do we have to do first? Well, first we need to determine the dilution factor because we don't know what that is, so we can't multiply our result by it. So to do that, we will figure out our total volume and then divide that by our initial volume, and we'll get our dilution. So we have 10 microliters of serum. We have 90 microliters of diluent. So our total volume is 100 microliters. And we'll divide that by 10, which is our initial serum sample amount. And we end up with 1 to 10 dilution and a dilution factor of 10. So next, we need to multiply the diluted result by the dilution factor. So we have 75 milligrams per deciliter was the result we got from the diluted specimen. And we multiply that by 10, which was the dilution factor we calculated. And our final result is going to be 750 milligrams per deciliter. So I want to just briefly touch on some different expressions of concentration. Concentration can be expressed as a dilution, a percentage. It can be expressed as milligrams per deciliter, or as molarity and normality. So next, we're going to talk about how to determine concentration after dilution, and we'll see a few of these different examples of concentrations. I don't want you guys to get hung up on the units. It's really the numbers that matter, okay? So determining concentration after dilution. The formula for this is original concentration times dilution equals new concentration. That's super simple, right? So let's walk through our example. We have a 0.5% sodium chloride solution, and it is diluted 1 to 10. What is the concentration of the resulting solution? So we want to know what's the concentration of our sodium chloride in that final dilution solution. So let's set up our formula. We have our original concentration, 0.5%, times our dilution, which is 1 to 10, and that equals our new concentration, which we will call X. So 0.5% times 1 over 10 equals X. So we can say X is equal to 0.5% divided by 10, which equals 0.05%. This is the concentration of the sodium chloride in the solution after the dilution. So here's the practice problem for this one. A 2 normal sodium hydroxide solution is diluted 1 to 25. What is the concentration of the diluted sodium hydroxide? So again, I don't want you guys to get hung up on these units. Let's focus more on the numbers. So let's set up our formula. We've got our original concentration is 2 normal. And we're going to multiply that by our dilution, 1 over 25. And that equals our new concentration, or X. So we can boil this down to X equals 2 normal times 1 over 25, which is equal to 2 normal divided by 25, which is equal to 0.08 normality. And that is going to be your concentration of sodium hydroxide after the dilution. And this would work too if you put percentage in there, or if you used 2 milligrams per deciliter, just whatever units you threw in there, it would still work. So again, just make sure you put your units in where you need to, but don't get hung up on those. A lot of us don't remember about normality and molarity, and that's okay right now. So just don't worry about those. Okay, so that's all from me, guys. Please, please, please let me know if you have any problems or if you're struggling with any of this. So there's a lot of resources out there, and I'm happy to guide you to those. I'm happy to create more practice problems for you to work through if you need to. All you have to do is email or call and just let me know, and I will do what I can to help you. Let me know if there's anything I can do for you guys.